Going to develop what is called the unit circle. Okay, so this is what's sitting in front of you. Why do we call it a unit circle? Okay, what number do you think of when you hear the word unit? 1. Okay, this is a unit circle because the radius is 1. Okay, and when we have a circle of radius 1, it actually gives us some information about the sine and cosine value based on the x and y coordinates. Okay? So we are going to develop the unit circle, and it's going to be a tool for us to evaluate trig functions of special angles without having to draw a triangle and without having to use our calculator. Okay? So on Friday, if I say, hey, what's the sine of 120 degrees? In about 5 seconds, you're going to be able to rattle it off back to me. Okay? Or that would be the goal. Okay? Now, there's lots of patterns in the unit circle, so we're going to use that to help us. Okay? So put your triangles off to the side, grab your pencil, and I want to talk about first the angles that we don't have to measure at all. Okay? So right here, we have 0 degrees, which is the same as 0 radians. Or if we come all the way back around, it's 360 degrees or 2 pi radians, right? If this is the origin and the radius is 1, what's this coordinate? This coordinate is 1, 0. If this is the origin and we go right 1, we're at the coordinate 1, 0. Up here, this is 90 degrees, which we had converted to pi over 2. If this is the origin, and we have a radius of 1, what's this coordinate? 0, 1. Over here, we have 180 degrees. Which is pi radians. If this is the origin, and we go left along our radius of 1, we're at the coordinate negative 1, 0. Okay, some of you are already filling in the last one. This is 270 degrees, or 3 pi over 2. That's a coordinate of 0, negative 1, because we have to go down. Tomorrow or Friday, I may give you a blank unit circle. Those are the 4 easiest coordinates. I would start there. I would fill those in first, and then I would fill in what we're about to fill in. So, what I would like you to do, you're going to have to take turns. Okay, so I'll be patient. What I want you to do, I want you to take turns using the we'll start with pink. What I have in red or pink. Okay? Take turns on both circles, highlighting these in pink, and then on your unit circle, fill in the degrees and radians. So if you're not using the highlighter, you're filling in the degrees and radians. I'll give you about 1 minute to alternate using the highlighter to highlight these lines right here. If you have your own highlighter, feel free. I'll see if I have one. We're only worried about pink right now, though. I only want you to do pink. I only want you to do pink. As you're filling these in, take notice of maybe the patterns. Only worry about the pink. Only worry about pink. The pink lines and the pink angles. What do you notice about all of those radian measurements for the pink angles? They are all something pi over 6. Do you see that? All of those pink angles that you're filling in, you have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. That is a pattern that I would take note of. Okay? Those are the 4 angles that are the closest to the x-axis. In degrees, how far are those pink angles from the x-axis? They are all 30 degrees. 30, 150, 210, and 330. Those are all 30 degrees away from the x-axis. They are all pi over 6 radians away from the x-axis. Okay? Who needs more time to do their pink angles? Okay. I would like you to grab your pink triangle. Okay? This is going to be our reference triangle. Okay? If I were to plot a coordinate on the xy plane, we move horizontally x and vertically y. Do you agree? That is how we're going to get these coordinates here. Okay? So when we're at 30 degrees, put your pink triangle there for me. You see how the 30 degrees is at the origin? How far horizontally would we have to move? Look at the bottom of your triangle. Radical 3 over 2. And then vertically, we move along this side, 1/2. So that coordinate is radical 3 over 2, 1/2. Okay. I should have done this all. Okay. Now, when you move it to the second quadrant, okay, the 30 degrees is still at the origin. Now, to get to that coordinate of 150 or 5 pi over 6, now we're moving left along radical 3 over 2 and up along 1/2. So this coordinate is negative radical 3 over 2, positive 1/2, because we move left and then up, but along those same sides. Interesting. Now, when we go to 210 degrees, or 7 pi over 6, what you're going to have to do is flip your triangle. So now the 30 degrees is in the third quadrant. Okay. Right angle is always along the x-axis. Right angle is along the x-axis here. Look at mine. Okay. We're going to have to move left, and then we're going to have to move down. So now we're moving left along this radical 3 over 2 side, and down along the 1/2 side. So this coordinate is negative radical 3 over 2, negative 1/2. Then take your triangle, flip it again to the fourth quadrant. Okay. So now our 30 degrees is in the fourth quadrant. Right angle is still along the x-axis. That's where it always goes. Now I'm moving right along this long leg and down along the short leg. So we're moving right radical 3 over 2 and down 1/2. So our coordinate is positive radical 3 over 2, negative 1. Look at those red coordinates, pink coordinates, whatever. Besides positives and negatives, what's true about all the x's? They're all square root of 3 over 2. What's true about all the y's? They're all 1/2. It just depends on which quadrant we're in, indicating if it's positive or negative. Okay, cool. What I'd like you to do now is I would like you to go to your green lines. I want you to highlight the green angles and fill those in with the degrees and radians. Fill in the degrees and radians of the green and take turns highlighting those lines. What do you notice about the radians of the green angles? What's their denominator? 3. Pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. There is a pi. We always think about the x-axis. I really don't care about the y-axis. But back to the x-axis in degrees, how far away are those green angles? They are all 60 degrees. In the first quadrant, we have 60 degrees. In the second quadrant, 120. In the third quadrant, 240. In the fourth quadrant, 300. Those are all 60 degrees away from the x-axis. They are all pi over 3 radians away from the x-axis. Okay. Do you think there's going to be a pattern? Gosh, I hope so, right? Okay, anybody need more time on their greens? All right, grab your green triangle. Now, the green triangle and the pink triangle are the same. Mine's going to be pink up here. Okay, I didn't make it green. And what you need to do is you need to find the 60-degree angle and put it, oh, that's not the one I want to do. Okay, so we have 60 pi over 3. You need the right angle, so it needs to look like this, like tall. The 60-degree angle needs to go right here at the origin. Okay, so we move horizontal and then vertical to get to our XY coordinate. So it looks like we're moving horizontally along the side that's 1/2 in length. And then we're going to move up vertically along the side that's radical 3 over 2 in length. So this coordinate right here is 1/2 radical 3 over 2. Hey, what's true about the x and y coordinate for 30 degrees and 60 degrees? They're flipped. So if you know the 30-degree coordinate, you know the 60-degree coordinate? Yes, you do. Okay? All right. So your triangle was here. Go ahead and flip it. So the 60 degrees is at the origin in the second quadrant. Okay. So now we're going to move left along the side that's 1/2. So we have negative 1/2 for our x coordinate, so since we moved left. And we're going to move up along our radical 3 over 2 side. So our coordinate is negative 1/2 radical 3 over 2. Okay. Now go ahead and rotate or flip your triangle. So now the 60 degrees is in the third quadrant. Okay. Now we're going to move to the left along the 1/2 side and then down along the radical 3 over 2 side. So our coordinate there is -1/2 negative radical 3 over 2. And then we're going to flip it one more time to the fourth quadrant. We're at 300 degrees, or 5 pi over 3. To get to this coordinate, we're going to move left 1/2, this is right 1/2, and then down radical 3 over 2. The four coordinates that we wrote in green, besides the positives and negatives, what's true about them? All of the x's are 1/2, and all of the y's are radical 3 over 2. If you know one coordinate, you know the next three. Okay. All right, last but not least, let's do our blue angles. Highlight in blue those ones in between and write in what their degree and radian measures are. What do you notice about the radian measurements of these blue angles? They're all something pi over 4. We have pi over 4, we have 3 pi over 4, 5 pi over 4, and 7 pi over 4. They're all pi over 4 away from the x-axis. All of those degree measurements are all 45 degrees away from the x-axis. So now, and these are the easiest, that's why I say thankful. Go ahead and grab your blue triangle. So with our blue triangle, okay, make sure that the 90-degree angle sits on the x-axis. Okay, with that 45 degrees right there, it looks like we're going to go right radical 2 over 2 and up radical 2 over 2. That's nice, like the x and y coordinate have the same number. Okay. All right, when we flip this over into the second quadrant for our 135-degree angle, it looks like we're going to go left radical 2 over 2 and up radical 2 over 2. In the third quadrant, it looks like we're going to go left radical 2 over 2 and down radical 2 over 2. And then in the fourth quadrant, it looks like we're going to go right radical 2 over 2 and then down radical 2 over 2. All the blue coordinates, except for the fact of the positives and negatives, all of them have x and y values of radical 2 over 2. So let's look. In the second quadrant, all of our x's are negative. In the third quadrant, x's and y's are negative. In the fourth quadrant, y's are negative. Okay. These three coordinates you see in the first quadrant, they get reflected to each quadrant where just the plus or minus of either the x or y is in. Okay. If you know these three coordinates right here, you know the whole circle. Okay. So I don't want you to look at this and think, oh my gosh, I have to remember 64 different numbers. You really don't. Okay. We need to know the degree and radian measurements. And other than that, you have three numbers to remember. 1/2, radical 3 over 2, and radical 2 over 2. That's it. If you know the 30-degree coordinate, you switch it and you know the 60. Okay. Now, what can we do? Here's where it gets exciting. On our unit circle, our x-coordinate represents the cosine of the angle, and the y-coordinate represents the sine of the angle. How would you write that? So if I ask you, hey, what is the sine of 135 degrees? I can come to 135 degrees and recall that the y-coordinate is radical 2 over 2. Boom, there's my answer. I don't have to draw a triangle or something like that. What is the cosine of 300 degrees? Here's 300 degrees. The x-coordinate is 1/2. The cosine of 300 degrees is 1/2. Those of you who took honors algebra 2, you might have had some, like, you had to fill in some of these quickly. I mean, not on the circle, but like what's the sine of 60 degrees, what's the cosine of 30 degrees, and you'll do that, right? Okay, this is like taking it to a whole new level. Okay? With this, we can figure out all of our trig functions. How do you know what the tangent is? Huh? The tangent is the same thing as sine over cosine. So we can take the y-coordinate over the x-coordinate, and boom, we have our tangent. Okay? And if we can do those three, then we can just take the reciprocal for each of the reciprocal functions. Okay. So if we can take this circle, and kind of put it in our brain, and recall these numbers, we'll be able to save some time and evaluate sine, cosine, tangent, etc. of these special angles. Okay? Some things I want to talk to you about before we get into evaluating with some examples. You might recall, you'll have to tell me if you did this or not. Does that look like 4 letters you've seen before? Okay. Maybe your teacher said all students take calculus. It's a way of like promoting you. Okay. Okay. What does it mean? Okay. These represent, out of the 3 main trig functions, which one are positive in that quadrant. So all of the 3 trig functions are positive in the first quadrant. X is positive, y is positive, so cosine and sine are both positive. Also, do you notice how x comma y is in alphabetical order? So does it make sense that cosine comma sine would also be in alphabetical order with the x, y? Okay, something for you to kind of help keep things straight. Okay. In the second quadrant, do you notice how our x's are negative? That means our cosine ratios would be negative, which would mean if our sine ratios are positive, sine over cosine would also be negative. So of the 3, sine is the only one that's positive in the second quadrant. Okay. In the third quadrant, both x and y coordinates are negative, so sine and cosine are both negative. However, when you take sine divided by cosine to get your tangent ratios, those become positive. So that's why we have a T in the third quadrant. Tangent is positive in the third quadrant. And then in the fourth quadrant, our Y's are negative, which means sine's negative. Our X's are positive, so all of our cosine ratios are positive. And sine divided by cosine would also be negative. So cosine's the only one that's positive in the fourth quadrant. All right, so this is what I need you to be able to do, at least for tonight. Okay? Tonight, you're going to have your unit circle in front of you to answer your homework questions. But by Friday, my hope is that you have the unit circle enough in your mind to where you can answer these questions without looking at the unit circle. Okay? Maybe you draw it in your head, or you think about these three coordinates in the first quadrant, but I don't want you to sit there and draw the entire thing out and then answer a question, because that's not a time saver either. What I want this is to be something that's in your head and we understand the patterns. Okay? I'm hoping that our colors can help kind of pop out those things that are all related. Okay, all of the pink coordinates are the same, all of the blue coordinates are the same, all of the green coordinates are the same. Okay. So let me just give you an example of what you might see in your homework tonight. I'm trying not to get too cluttered up here, but I also want to be able to record this for people who aren't here. So bear with me. Can you see that? Yeah, you can see that? No problem? I don't know. I need to go back to it. So if I give you, theta is 5 pi over 6. Let's talk about what all the trig functions would be at 5 pi over 6. So if I ask you for sine, cosine, and tangent. Okay. Well, here's 5 pi over 6 right here. Okay. Our x is negative radical 3 over 2, so that's our cosine ratio. Our y coordinate is 1/2, so that's our sine ratio. In order to get our tangent ratio, we are going to have to take sine and divide it by cosine. Well, we have a fraction and a fraction. The 2's cancel out, and we have negative 1 over radical 3, which we would then have to rationalize to negative radical 3 over 3. Okay, I'm going to run out of room, so let me come over here. For our reciprocal functions, we would have the cosecant of 5 pi over 6 is going to be the reciprocal of sine, so 2 over 1. The secant of 5 pi over 6 would be the reciprocal of cosine, so 2 over radical 3 negative. But you never want to leave a radical in the denominator, so you would need to rationalize. And then our cotangent, you can think of this 2 different ways. You can think of it as the reciprocal of tangent, or you can think of it as the reciprocal of sine over cosine. So if you want to do cosine over sine, right, that's fine. But we end up getting negative radical 3 over 1. You can either flip this and rationalize it, or you can think about cosine over sine, and those cancel to get there. Let's talk about another one. Kaden, did you get your question answered? You did? Okay, good. All right, let's talk about, pick an angle that doesn't have a color. 90? Sounds great. I'm going to call it pi over 2, just so we get used to our radian measures. Okay. Okay. Here especially, we have to use the unit circle. There's no way for us to draw a triangle where we can do sine, cosine, and tangent. Okay? So look at the coordinate. Our sine ratio is the y coordinate. Our cosine ratio is the x coordinate. Our tangent ratio is sine over cosine. Undefined. We cannot divide by 0. One divided by 0, we cannot do. All right. Now let's talk about our reciprocals. Cosecant is the reciprocal of sine. Okay, well that's just one. That was bad. Okay. But what if I ask you about secant? The secant of pi over 2 is the reciprocal of cosine. Reciprocal means 1 over whatever it was. Well, what's the reciprocal of 0? Undefined. What about the cotangent? It would be 0. So the cotangent we can think of as cosine over sine or x over y. In this case, that would be 0 over 1, which is 0. Okay. Notice how the reciprocal of 0 is undefined. The reciprocal of undefined is 0. That's going to happen, especially at those quadrantal angles with some of your ratios. What questions can I answer? Yes. Right. All of these angles that we have that are on, like, in between the quadrants, they're going to look like this. They're just going to be in different orders, or like the negative one instead of the positive one. But yes. Okay.
Will we ever have to do one that's like secondary degrees or something?
Not from the unit circle. That's something that we could use like right triangle trig for, but all of our quick recall unit circle will be anything from a 30, 45, or 60 degree angle. Okay? These are all no calculator. Yes. So my advice to you for tonight is to have your unit circle in front of you as you're answering the questions. Also, like, kind of recognizing the patterns and putting those in your brain. Tomorrow we're going to do some more work with the unit circle and using it, but by Friday, well really by the end of class tomorrow, we're going to practice doing this without looking at our unit circle. Yes? Oh, so that means like by 3. So if you do 3, skip 2, the third one's what you do. So basically, you do 1, you skip 2, you do the third one. You skip 2, you do that third one. Okay. In my opinion, I've been teaching the unit circle for years. In my opinion, if you can think about the first quadrant, then you can reflect it and get to anywhere you need to for any of the other angles. Okay? Like if you know that at pi over 6, your coordinate is radical 3 over 2 1/2, then if you have any sort of other, whatever pi over 6, you can think about x, y, and then just think about the positives and negatives for each quadrant. Okay? That would be my advice to you. If you know the first quadrant, you are good. You have 3 numbers to remember. Where does radical 3 over 2 go? Where does 1/2 go? And where does radical 2 over 2 go? Please spend time with your unit circles tonight. Most of you have done this, but make sure all the triangles get put back in the baggies for my next class. If you could just come up and make piles of your markers / highlighters and the Ziploc baggies up here, I would appreciate that.